All right, I think we're going to get started in just a minute. Well, I appreciate everyone who has braved the terrible outdoors for a whole 30 minutes to an hour of commute to come join us today. We appreciate your sacrifice, truly, truly we do. As well, I appreciate you guys being here because this was originally not on the agenda. Actually, we added it yesterday afternoon, and this was a talk I haven't given since October, so polished it up this morning a little bit. But I still think you guys are going to get a lot of value out of it. And let's go ahead and get started, I guess. This is Resilient by Design, building reliable workloads on Azure. My name is Chris Ayers. I'm a senior software engineer at Microsoft. Actually, my team has changed. It used to be CXP in Azure Engineering. Now it's Engineering Ops. So I'm still on the APRL team, and my whole job is looking at Azure reliability. So when there's an outage or an incident on the Azure platform, I'm one of the teams that looks at that. I try to figure out why it happened and how to make sure it doesn't happen ever again so that we improve the reliability of our system. Like, that is my team's mandate. Look at outages on Azure. And I've been doing this for over a year now. I'm on all the socials. All my talks, all my demos, all my everything are out on GitHub. So GitHub Codebytes, if you go there, you'll find all my talks like this one because everything's just hosted in GitHub Pages in Markdown. And I just pushed some changes a little bit ago. This is the Azure Resiliency one, but everything's there, so you can get this right now. So let's talk about reliability a little bit. Means a lot of things to a lot of people, but it matters that we're delivering essentially a consistent experience to our customers. Doesn't matter if there's performance or load, whatever, that we understand what the core requirements and function of our system is, and no matter what's happening, those users get that experience. Like, that is the goal of reliability. It might be HA, it might be resiliency, but like all of these things kind of go together. And that means that when something happens, and it will happen, that we get back as quickly as possible. Now, like I said, failures always happen, but your workload needs to know it happened. Like, who's had your customer tell you something's down? That's bad. Like, you should have an observability or monitoring system. You should know it's down. Like, Microsoft has sent, we're like, uh-oh, that's a customer-reported incident. That's not good. Our detections, our monitoring isn't up to snuff. We need to make an adjustment. Down detector says it's down, but our stuff doesn't. What's going on? Like, where's the problem? All these failures don't just impact sales. Like, it's not just, oh, Walmart's down, they can't take money. There's brand impact. There's reputation impact. And there could be legal requirements, like legal things going on with this. Like, say, failure is always an option. And if you're an SRE, you know that. Like, you have to accept something's going to fail. How do you deal with it? I've seen businesses lose, just in sales, millions per hour. We've seen increased expenses. And this is the thing a lot of people don't think about. Let's say your stuff goes down. Now you have teams on call. Maybe you have to switch over to secondary systems and you're paying for 2 systems at once, or you're paying for data recovery, or you're paying for additional downtime for people to do things overnight and off hours. So costs go up just in personnel cost, material cost, expenditures on recovery services, like all of these things happen. There might be legal liabilities. So SLAs are real things, but those are things of lawyers and companies. And when SLAs are breached, then suing can happen, and lawsuits, and payouts. And those have a bigger impact on top of all the things you've already paid. You might have increased insurance. So if you start having lots of outages, that can lead to insurance costs going up, which leads to an overall higher expenditure. All of these things can affect your organization and why you want to be as resilient as possible. On average, 77 hours of downtime for really high impact outages with a tremendous amount of annual costs. There's a lot of engineering time spent at Microsoft and at other large organizations on trying to mitigate disruptions and fixes and things. Like this came from the New Relic observability forecast. Like these are a lot bigger than you think they would be. Now I was told there would be reliability. Who's had a manager or boss that wants 100% uptime? Okay, cool. So let's talk about that. 3 nines, annual downtime of 8 hours. Everybody's got their systems up all the time, right? You don't do 8 hours of patching and rebooting an annual, no. You know, because we want 5 nines, so we get 5 minutes a year, because we're just that good. I always say this is an exponential growth curve in cost, because every time you do a thing, it costs more. I love this website. Does anyone know about Uptime Is? Does anyone play with this website? Oh, cool. So Uptime Is a great website. So you can come in here and you can like put in your numbers and just like hit enter and then see the daily, weekly, and yearly. So 4.5 nines is 26 minutes. So you can play with these. But what's also awesome is they have this dynamic, oh, why is it not picking up my click? There we go. You can do this reverse. So you'd be like, hey, we had a 1 hour downtime. And it'll tell you what your uptime is. Pretty neat, right? 5 nines is hard. 5 nines is expensive. 5 nines is complex. We'll come back to that. So one does not simply achieve 100% uptime. Like this just does not happen. You don't fall into reliability. You don't add it as a coat of paint to your solution after it's already built. You need to think about these things early, starting at like how you measure it and what are your requirements. So you're going to hear about SLIs, SLOs, error budgets, and SLAs. So SLIs are those things that we measure, like our user experience metric, our P95 latency. We just look at what is the thing we measure. And then an SLO is what is the thing we measure over time. So we want 99% uptime. That's the thing we measure. What's our uptime? What's our uptime over the month? That's our SLO. And then you might have an SLA that is a contractually defined number that's very similar to your SLO. That might mean rebates and credits to customers. Error budgets are a thing the SRE community uses a lot. So a lot of times we just build and push software, And you don't think about, hey, you know what? We've been getting a lot of outages lately. Maybe those last couple changes made our system a little bit more brittle. Our system's a little unstable right now. Maybe we should stop working on new features and we should just kind of direct our energy to stabilizing our system. This is where the idea of an error budget comes in. It's like, how many allowable failures are we allowed to have every month or quarter or year? So we've got a budget. And oh, we've been out 30 minutes this month. We're kind of blowing our budget. We got to start switching our focus more towards stabilizing the system. Another metric you might hear about is RPO and RTO. This is the data reliability thing. So when an incident happens, how much data can we afford to lose? So like if we synchronize every 15 minutes, we can lose up to 15 minutes of data. Okay, cool. Well, we may have lost 15 minutes. How long until we get back? How long until we can start working again? Like, cool, we didn't lose any data, but it's going to take 2 days to restore. So like these are all things that are requirements that we need to know. Like you can't just say I want it up all the time. It's like, cool, let's talk about the specific numbers. These are the business and non-functional requirements we need to discuss. Like these are the things we need to know. Like as a user, what's my experience? What is my user journey? I need to be able to sign in, add something to a cart, check out, take my money. That's the critical flow. Recommendation system? Maybe not. You know, like you need to understand like all the bells and whistles and cool things that salespeople want to sell. Sometimes those are not the critical path to the application and the core functionality that you need. So what are those critical journeys? What are some of the SLOs? What is the error budget? What is the RPO? What are the things we care about? Do we care about reliability more than performance? Do we try to keep the cost down? This is where we have to have the discussions earlier in the process as we design it. What is success? What are our different components that matter? Because we might have an email flow. Like I'm sure you've worked on e-commerce site or dealt with an e-commerce site where it doesn't take your money right away. It goes, thank you, we have your order. Just an acknowledgement that they put it in a queue somewhere. They haven't done anything with it, but they have it. And then later you go, hey, they've charged you, we've charged you for your purchase. And then like those are different flows from I accept it to I paid it offline. Do you have compliance? This is one that a lot of people don't think about. Do you have regulatory compliance stuff in your region or in your country? Some of those requirements affect resiliency. Can you have another stamp in another country? Can you back up your data somewhere else? Or does it have to be in the same data center or same region? Those are options that we need to think about. Sometimes you've done a purchase order through your cloud or your data center, and so you have to meet certain things, or they might have SLAs that you can leverage. So understanding all of the flows and dependencies are really important just at the business layer before we start building. We've gone through, we've figured out each of our components, which ones are critical. Maybe we can turn off the recommendations on Black Friday because we want, or Boxing Day, because we want people to buy things and we don't really care about recommending something else. We just want the orders to flow through. We'll add more to their cart later. What are the failure points? Like how can your system, and we'll talk about these a little bit more, what are the places your system can break? Like have you thought about every place that you could play Jenga and you just push a little bit, your system's gonna fall over? Your queue gets too big. Can you isolate bits? Can you scale bits? So where are places we can recover? So what are our data stores? So having that idea of, well, here's our customer records, here's our order records. These are areas we need to repair and recover and restore. So these are all things to keep in mind as you build your requirements. And the last thing is, most people don't think about how to run it. Anyone had a really cool resilient system, but the steps to help make it scale or recover are remote into this server and run this command to click this button? So if you're on call and you're on vacation and you need to recover something, it's like, oh, I can't get the guy. He didn't bring his laptop on vacation, so we can't actually recover that. Someone's got to drive over and do a thing. Like, has anyone had that type of problem where it's a super manual process to scale and recover? Yeah, it is a nightmare. Operational aspects are super important, and that includes monitoring, educating the team, prioritizing automation. All these things feed into reliability. Start simple, keep it simple, don't over-engineer it, don't over-architect it, but like look for opportunities to improve. All right, so we've got some requirements. We gotta have trade-offs. Everything can't be the most important thing in the world. Some things are more important than others. They have to be, those critical flows. And so that's how we're gonna prioritize our impact and prioritize things. So I've helped a lot of customers with reliability, and every single customer that's never had an outage does this. They get stuck on cost every time because it doesn't hurt. It's not important. They've never had the outage. I was helping somebody that was doing some broadcast stuff for the Olympics, and I've helped some really major warehouse e-commerce people in the US, and they hadn't had an outage. And so, sure we need 3 instances? Maybe we can do 2. Sure we need that SKU? You sure we need 2 or 3 replicas in different regions? Like maybe we can just keep the costs a little bit down. And then they have an outage, and they lose millions. And it's like, okay, yeah, can we have 6 instances? Can we like up the SKU? Can we have 5 more? Like they just never want to have that happen again. One of the great tools you guys can reference is the Azure well-architected framework. It has a lot of pillars. There are 5 pillars, and each pillar has trade-offs, recommendation guides, checklists. It also has roles of the people involved with that, and there's a lot of really cool tools that we're going to dive into that are available. So I've got the link here in the deck. You'll see the well-architected framework just right out on the Azure architected site. And we've got pillars, workloads, service guides, design essentials. There's even like a path, path forward. Why is this not closing? There we go. Whoops. So cost optimization, security, reliability, operational excellence, and performance efficiency. There's Advisor, so you can actually have it point at your existing Azure implementation. It'll give you recommendations. You'll see some of these in Advisor. But then we're going to dive a little bit into service guides as well. So if you know you're using a certain Azure resource, there's specific guides for that resource on settings to change for security, for reliability, for cost. And you can go and reference those and actually look at what you've done to your own deployments and compare them against best practice guides. I helped write some of these, and so did some of my team, as well as people in like the app service team helped write the app service guide, and we worked with the storage team to write the storage guide. So it's the people writing the service along with experts that have been in the field doing stuff with customers. Each of these is interdependent, I think. Reliability and operational excellence, I think, touch all aspects across the board, and I think they feed into all the other ones a little bit, but there's definitely a push-pull that we're going to talk about, like these trade-offs. So like cost. Cost always wants you to have one instance, one region, like minimize things. But with reliability, we're going to maybe need bigger setups in a region, more availability zones, and so there's that push-pull between cost and reliability. It also, can affect things with performance. Performance wants to crank it to 11, cost wants you to crank it to 1. Security. As we have lots of backups and replication, that's a bigger attack surface. Like someone could potentially get your backup and get your data. So like not everyone thinks about that. Or it might be we want to recover, but we've got extra security in place with more identities, and so now we have to do break class accounts and permissions, and there's 3 people in the chain to get approvals to do the recovery that could slow things down. Or we want to run a version or 2 behind because it's stable, and we don't want to get on the latest version because it might cause stability. So there's that push and pull between reliability and security. Same with operational excellence. As we start doing multiple regions and multiple configurations, that's more complex. It's harder to deploy, harder to recover from. There's more documentation and training that need to be needed. And we might want to do more testing, load testing, chaos testing. And so that adds some headaches to operational excellence. And then performance. Like if you're doing a multi-region right, that could slow down your performance. Now you might be pulling things apart into queues and CQRS, and so you have eventual consistency, which could impact your performance. Or you have failover logic and retry logic that could introduce additional delays into high performance communications. Or you might be over provisioned. Like there's just lots of little things that add up with the different pillars, having this push-pull with reliability. But this is the lens we can use. Remember, we're prioritizing our business requirements. We know the critical flows. We've ideally talked about them before we get to drawing boxes and arrows, because we don't just start with boxes and arrows, right? Or lines of code. We think it through a little first, right? Hopefully. Or we just throw it in a Ralph loop. Yeah, okay. So failure mode analysis is something that I don't think everybody knows about, but it's really something you should do. What are all the ways your system could break? Like literally. What happens if auth fails? What if front door goes down? Or your traffic manager? What if the app service goes down? Or you deployed bad code? Or there was a version mismatch on something and it can't pull the Docker feed and now the Docker container won't spin up? What if the data storage fails or it gets corrupted and you have to do a recovery? Like, these are all the things. So there's actually some cool examples that Microsoft has put out. Like you can see this. Let me just zoom in a little bit. So this is an example from that well-architected framework on resiliency, and there's a whole article here on failure mode analysis. So let's just take the first couple. Like Entra ID. The risk is our service outage. Like, we're worried about that. But what's the likelihood, ignore the last 2 months, what's the likelihood that maybe Entra ID goes down? On average, it's low. It's hopefully getting lower if I'm doing my job. But what happens when Entra goes down? Like, we got a full outage. Like, we're down. Can you fix it? Can you just like flip the switch? And no, we got to wait on Microsoft to remediate. That's one failure mode. Let's just scroll down a little bit. What about SQL? Maybe someone's trying to attack us. They're doing a malicious attack, and it's a medium risk. We're constantly under attack. Well, what happens if they do? Well, it's probably a lower risk, sorry. But like, this is the thought process. Like, look at each different attack vector. DDoS, an availability zone goes out, a region goes out, misconfiguration. Like, these are all the different ways you could break your system. Like, have you taken a deep look at each box and each arrow in your architecture and gone, well, we always talk happy path. This is how the data flows. What happens when it doesn't? Like, have you taken that time? Who's spent time doing a failure mode analysis? As thoroughly as you need to?
To be brutally honest, no. But it's hard to say because, I have, in the most recent case, I've got an idea of where those failure points are anyway.
Yeah.
So I'm wondering whether that sort of queers the pitch a bit, if I could use that expression. It sort of forces me to look at certain things and maybe not think about other things that I possibly should think about. So like unknown.
Yep, yeah. And that's the point. Like, there are things that are high incidence. Those are the ones you want to focus on. There are some low incidence ones that probably won't happen. There's probably not a lot you can do about it. So this is where prioritization is, again, key. Prioritize the things that are high risk and high likelihood. Like, that's what you focus on. The things that will happen often and will probably hurt you. Single points of failure are a great one. Let's say you have one VM deployed or one endpoint and you don't have it load balanced across multiple things. A single component that if it goes out, it takes out your whole system. SPOFs are one of the biggest threats to redundancy. This is actually a work stream that we're looking at for some providers inside Microsoft. Like, this is something we look for, but this is also something customers need to look for their own solutions. You can configure something to be multiple instances, multiple things, and you're fine. You can configure things to be really insecure and really unreliable with one instance on the lowest SKU. So like, it really can go either way. Another like way to think about how you're going to architect is, are you going to be doing active-active? Are you going to have double infrastructure always running with maybe data flowing between the two stamps, two complete stamps with like log shipping or regional-based stamps? Or are you going to do an active-passive where you're only taking traffic into an active region and in the back end you're shipping data and at some point you might fail over? So you're trying to minimize cost by having a standby. Like, these are design choices that come up through that business discussion. So in our boxes and arrows, as we start getting to one box, we go, how do we minimize those? How do we minimize those SPOFs? How do we like isolate faults, and try to look at those places? So Azure gives you some things that you can do as well at the infrastructure and platform layer. There's a couple of different options we have, and there's some patterns that we give you. First is there's the shared responsibility model. So I'm sure a lot of you guys have seen that picture in the left-hand side. If you haven't, this is the idea of IaaS to SaaS. So like, if you're on-prem, if you're in a data center, you control it all. You have to worry about data. You have to worry about networking. You have to worry about power. You have to worry about that stuff. And you might be buying it from a building, but you're picking and choosing, and that's on you. Like the physical cables, maybe you own a rack and you go in there and plug stuff in. But once you get on to Azure, like, we handle all of that. But let's say you run a VM. You still have to patch the OS and encrypt your data and do backups. Like, you have to do that. So you have to pay someone to do patching and updates and rebooting multiple machines. You have to install the network configurations and controls, install the applications. You do all of that. As you start sifting in the paths and you're using like an app service, you push your code up and you worry about your data and your identities. Like, we handle the underlying OS and we handle the underlying software that's running things, and you worry about your app and your code and your identity. And when you get to SaaS, you don't even worry about that. You sign in and you worry about your data. And most of them have, like at the Trust Center and other ones, like, there'll be backups, there'll be ways to recover your data on the SaaS side, even on some of the PaaS side. But it starts shifting away from you, but at every point, you really need to think about your data, like your app, especially if you're deploying to containers or app service or anything like that. What's your retry logic? Do you have circuit breakers? Do you depend on a flaky downstream system that's going to take your whole system down? Or did you add stuff into your architecture to kind of limit you when it does? Do you have good isolation on identity? And did you set it up so that maybe you have multiple network stuff? Or you're using multiple zones? Like, do you have multiple stamps of it? So this is where you need to think about your responsibility. Azure has a platform SDK. You have an SDK. They're not the same thing. Like, you need to own your own workload as SLA. There's lots of regions. There's like 60-something regions. A lot of times you'll do proximity to users. There is a speed test. You might have strict requirements about data sovereignty and data residency. There are some services that are available in some regions and not others, just like capacity in some regions, not others. We also have the idea of region pairs. So in the US, that's like East and West, East 2 and Central. They have prioritized recovery. So like, if one goes down, a lot of people are going to move to the other one, and they'll prioritize one of those pairs coming back. You can also just pick whatever regions you want, as you want. We also have some sovereign clouds in the US, France, China, Germany. And pairing does not equal automatic failover. You have to design for that. And this is the idea of availability zones. Who's already using availability zones? Okay. So if you pick an Azure geography, a region, ideally it should be 2 to 3 data centers. Each are geographically distinct. So they try to be far enough apart that if an asteroid hit one, it wouldn't take them all out, ideally. But they have independent power and cooling and water. And so you can deploy to it, and if one region or one zone goes down, you should still be operating just fine with the other 2 zones. There are low latency connections. They do updates one at a time, and I love this view. This is cool. So we have all sorts of regions, and you can see if they have paired and availability zone support. And I'm sorry if the checkbox is a little hard to see. But you can see we have quite a few that do and do not. We have quite a few with paired regions and their general availability. But the other cool thing about this is, as we start getting into zones and services, there are really 2 types of services. There is the zone redundant and zonal. And we do have non-zonal, which would be like front door. Front door is a global service, so it's non-zonal. So zone resilient, when you do that, it will survive zone failure. So if we look at some of the services here, you'll see that zone redundant and zonal. So like API management, you can deploy it zonally. So you could put it into a zone, or you could just use it zone redundantly. Most services are zone redundant out of the box. There's a couple that are not. But understanding that you have this choice is good to know, and we're trying to make pretty much every service we can zone redundant. Now, when I talk about zonal, and zone redundant, this is what I mean. If there's multiple data centers available and I deploy something zonally, and I say zone 1, I'm going to deploy maybe a storage account and a VM by itself in zone 1. I've got an app, but that's probably a single point of failure. If that zone 1 goes down, my app goes down. So maybe I want to deploy it to all 3 zones, but I have to make it zone redundant. I have to put a load balancer in front of it. I choose to deploy it in 1, 2, 3. I have to choose to do some sort of data synchronization on the back end. When I use zonal services, I have to make it zone redundant on my own. I have to do it. I have to handle failover. I have to choose active-active, active-passive. This is not automatic, okay? Now, if you use something like a VM scale set, and you go, I want a VM scale set over zones 1, 2, 3, and I want 3 instances, you get this. We automatically spread it over them on the back end. We automatically load balance for you amongst them, and we handle the distribution and data request and failover. So this is the difference between building your own redundancy with zonal services and using zone redundant services. This is like, I have a storage account with LRS. So it's locally redundant storage in a zone versus I have storage account with ZRS, like zone redundant storage. So this is so you can build whatever you want, but you're just taking on more ownership and more responsibility. But remember, you have to manage your own SLA. Now, like I said, storage. A lot of times LRS is great for dev test. And it is just, and I know that's really hard to see, but that first one, LRS, you're going to have multiple replicas. You're going to have 9 replicas, but it's going to be in one data center. It's not all over the place. ZRS is where you start getting it into multiple data centers load balanced across. So one zone can still go out and you'll still be serving that data. And then there's GRS, which is globally redundant, and then RAGRS. So you can read from your secondary region. Instead of just backing up to the secondary region, you can also read from the secondary region. So remember RPO and RTO? This is why sometimes those SKUs are important, and people are like, do we really need GRS? You might, if it's important to you. These are tools that you can choose. Don't blame us when you choose the wrong one. So that's infrastructure layer. It gives you lots of tools. What about the software layer? Who thinks about software with resiliency? Not the hardware. A lot of people think about hardware with resiliency. We got multiple copies of this stuff. But what about the choices and the things you're doing in your software? Nice. So, load testing. Who load tests? Cool. Same couple of hands I'm seeing have some good practices. So there's lots of different types of load tests, by the way. There's the load test where you've got your SLA of 100 requests a second. Cool. Let's set it at 100 requests a second. That's a good smoke test. Do we meet our SLA? Let's let it run for 4 hours. Does something inside of our software start building up a really big queue and then it falls on its face after 2.5 hours? Or did you meet your SLA for 1 hour and then you kind of turned it off and didn't pay attention? Do you do a spike test where you go 2 times your SLA and then drop it back down and see if you recover? Or a smoke test and just stress it to hell and just crank it up to 11 and wait and see where your system breaks? These are all different types of load tests that you can do. And it's better finding it now than finding it on a big holiday where everyone's hitting your website, going viral. There is an Azure load testing service you can use. There's JMeter. There's all sorts of different ones out there. But this is an important way to find those spots and find those misconfigured SKUs. Another great one that I recommend to people is resiliency testing through chaos. And what that means is simulating a failure. What happens if we reboot a node? What happens if we simulate a network outage for a service? Does our system gracefully turn it off or fail over? Does it scale up? Can we introduce network latency? At what point does it start messing with our queues? All of those. These are options you can run, and a lot of times organizations, we do it a lot at Microsoft, will have game days. So we'll do a game day, and during work hours, do a chaos test in one of our deployments and start testing things out to see if we understand what's happening properly. There's all sorts of things that you need to handle with resiliency patterns. And some of these you can do in software, some of these you can do in configuration, like having timeouts. Like if you just send off a request and don't put a timeout on it, you're just sitting there waiting, that's gonna hold up resources. Let's say a region goes down and it comes back up and everybody retries at the same, everyone tries to hit it at the same time and they need to retry. So you want exponential back off with some jitters so that they don't all come back again in 2 seconds and all do the same request at the exact same time. You gotta think through what happens when it comes back. Circuit breaker, so if you got that bad dependency, that you kind of turn it off for a bit and you check later. Bulkhead isolation, dead letter queuing, graceful degradation, using software patterns to help keep the system going. Like it's not just the requirements, or the boxes and arrows, or the platform. We're in the code now, our software design. We recommend using the SDKs. So a lot of people, when they call Azure, will call like just the REST endpoints. I highly recommend the SDKs. The SDKs implement all of these things. These are baked into each of the SDKs out of the box in all the different languages you leverage. So when you do it, you get retry. You get item potency. So if you're creating and doing a call, it'll understand you already made that request and we'll do it again. It'll do timeouts. It'll handle throttling. It'll do circuit breaking. So if you don't want to have to code all of these things yourself, these are baked into the SDKs. Python, .NET, Java, NPM, like these are there. They'll reuse connections. They'll have tracing IDs, so you can do distributed tracing. Yeah. So if you're not using the SDKs, look at the SDKs. Now, let's look at operations and observability. The industry's moved towards OpenTelemetry. If you're not looking at OpenTelemetry, look at OpenTelemetry. App Insight supports it. Log Analytics supports it. It's used pretty much by everywhere. So Azure Monitor, all the clouds. You know, we got multiple vendors out there that talk about it. It's built into .NET. You can easily add it to Python and Java. Having good metrics are important. Those help feed your error budgets. So if our metric is, you know, we got 99.5% total, requests, we're doing good. Most of them are under our threshold. That's awesome. We have a little bit of budget. We can start looking at these. If this number gets too high consistently and we start burning through our budget, we want to start freezing those risky deployments. We want to start maybe slowing down our change volume and looking at mitigations, or we just continue doing stuff normally. It really bases on what our observability is telling us. This is why observability is important. So we know how we're doing. One thing that's been added recently in the past 6 months or so to Azure is the idea of service groups, because that lets you look at the observability of groups of resources. Does everybody deploy everything into one big resource group all the time? One big resource group, one big subscription? Hopefully not. So now we're dealing with the idea of maybe we got some data resources over here in a data resource group, and we got some networking resources over here and our compute over here. Service groups let you aggregate all of those different things into a service group. You can link resources across resource groups, subscriptions. You can do it with permission model. You can do role-based. And so you can have an easy way to look at the holistic solution now. There's even the idea that we've started talking about with mission-critical health monitoring, where we start looking at what does 500 requests mean? Is that number good or bad? So starting to assign ranges and numbers to individual metrics so that it gives you context. Because you might not know, our CPU is supposed to be at 80%. Some services 80% CPU is bad. Some services 80% CPU is good. What does the number mean? So applying some of that modeling helps. And let me just go back here for 1 sec. So service groups, yeah. Yeah, this is why I like it, because with the service groups, You can cross resources across subscriptions, across resource groups of different types to get a more holistic view of your service. So service groups really bring a really good visibility there. And then the mission critical health monitoring. This is where, like I said, you're looking at the system as a whole and all of the numbers as a whole to try to understand what is healthy. So like really thinking about what healthy means for our service. The biggest thing with observability is start small. Like if you have an outage that's customer reported, find out how it happened and start adding a metric or a measure so that you can see that same kind of indication and start tracking it. Do those game days, like update your documentation. Like this is how you want to really start with observability, like one at a time. So let's look at some tools and things that we get that are going to help us enforce this. A little bit of governance and a little bit of enablement. Because it's hard to start from scratch, but if you have some toolkits and some frameworks, they can really help you out. One is landing zones. And I know that landing zones are a dirty word for some organizations. They've seen the big, massive picture and go, this is way too much. Who thinks landing zones is a dirty word? Oh, you've been enlightened maybe. Okay. So usually what happens is this picture comes up and people go, what? And I know, this is an enterprise landing zone. It's enterprisey. Come on, it's got more boxes and more arrows because it's enterprise. But there's a reason for this. Who likes to get hacked? Oh, okay. Who likes their data lost? Okay, so these things have a reason. And once you understand them, it makes perfect sense. For one is, there's management groups, which is how you can do permissions. And permissions are hierarchical. So you can have different management groups for how you set out the collections of subscriptions and the collections of identities. So there's usually one that's just identity, and then we have some subscriptions that are just security. We want security isolated from everything else so that we can see the logs and we can correlate and we know what's going on. And it doesn't matter if this gets hacked, that doesn't. We also have a connection subscription because you only work in the cloud, right? You never talk to a data center or have workers at their home office, or none of that ever happens. But having connection subscriptions where you can set up your VPNs and monitoring and firewalls so you worry about one ingress into your network and everything else is isolated. There's the identity subscription where all of your different tenants are. So there's an intent behind each of us. How much is a new subscription in Azure? 0. Like it's just a bucket. These are just logical buckets. So this is just like architecting your code to be modular. This is architecting your infrastructure to be modular. Maybe a sandbox subscription or a platform DevOps subscription. You don't have to have all of these. A lot of these are pick and choose. But the core idea is for each application, you might have a different subscription so you can isolate things. If your keys get lost or somebody hacks it, you can put a cap on each subscription so that it doesn't just start spending tens of thousands of dollars and it blows up into the rest of the company. It's about isolation to keep everything protected. So this might be an extreme, but there are less extreme versions that have a lot of the same concepts. So landing zone doesn't have to be a dirty word. It just doesn't also have to be that. Okay? I'm just saying this is there for a reason. Yeah. Who remembers the Azure Architecture Center? Anyone ever use it? I used to use it a lot. And then years ago, what it turned into was a website full of boxes and arrows that didn't have anything. There was no code behind it. It was like, hey, I'm a CSA at Microsoft and I need to show impact this quarter, so I'm going to put an architecture out there on the Architecture Center. Boxes and arrows. It wasn't helpful. But now, it has been completely revamped. We got rid of all that crap. So you can come in here and like browse the architecture. So, and these are good architectures. Like these have good things behind them. So let's say I want to do a baseline architecture for AKS. I'm going to have the topology and like different things we can do, how we might want to integrate it. There are why you make certain choices, why you're deciding certain tech stacks, some of the options you have. They're like, we picked this because of this thing. Hey, look, we've got our monitor over here for this thing. We want to use traffic for ingress, and we want to do virtual servers and keep, like, it will walk through everything. And then at the bottom, in addition to giving you links and references and how to configure and update these, almost every single case there is a reference deployment out on GitHub. And you can click there, and there's bicep templates and Terraform templates that you can leverage to deploy. So the Architecture Center, if you haven't been checking it out in a while, I would highly recommend it. All right, got about 15 minutes. So back to the well-architected framework. There's also these well-architected workloads, and these are very similar to the Architecture Center. On the left here, these are workloads that we have designed in the lens of the well-architected framework. So reliability, security, optimization, performance, all of that. So maybe you have a SaaS tool you're building, or SAP. Maybe you're trying to build an AI platform. This has all of that. So where our design principles, our application concepts, design methodology, hey, we want to be experimental, we want responsibility, here's our design areas. Like, fully goes through it. Components, pipelines, code, helping you get a leg up starting designing these things so you don't have to start from scratch. These are all off of the well-architected framework, just that workloads at the top. We also have, if you're trying to build those reliable solutions, mission-critical workloads. Again, so you don't have to start from scratch. We've got them in both .NET and Java. So these are focused on reliability and focused on security, because if your system gets hacked, it's not very reliable. It walks through all of the different options and choices you have for your SLOs and things you can do with it, like maybe using a regional stamp, and if you want to scale out, adding additional stamps and ramping up as your requirements do. Because we don't all start out as Walmart. Sometimes we're just setting up a web page for the corner shop. All right, so I want to get to some cool tools I know you guys haven't heard about. And then there's the enterprise web app patterns as well. So these are all toolkits that you can start building out. So the reliable web app pattern, and I'll just pick .NET. Yeah, so this one is like, we want to go from on-prem and deploy our web code up to an app host, a web app. Azure web app with private endpoints and caching and database. This reliable web app pattern, this is the one for if you're using IIS or Apache or something like that today. This is a great way to go from on-prem to the cloud and have a reliable regional stamp model ready to go. Now, let's say you want to do containers instead. Let's look at the modern web app pattern. And maybe I'll do Java. Maybe you're doing something in Spring. Well, here's our container platform with decoupled services. And we have our container registry, and all of these things are accessible via private endpoints. So we've got security and scalability in place. And if we want, let's just expand that stamp out and move our stamp to another region. We can have 2 regions with load balancing. So we're trying to give you guys some patterns to go out and take this code, like literally take this code. I just gotta find the GitHub link. Yeah, here's the reference implementation. Take it, build it, deploy it, push it out. So, and then I do a lot of infrastructure as code. I use Bicep, I use Terraform. I recommend AVMs. If you haven't used them, AVMs are Azure verified modules. So we've had 3 or 4 other initiatives in the past for standard templates like the Bicep registry. This brings them all together. And every module is pre-configured for well-architected framework. So it's got security and reliability in mind. Every module pretty much has a Microsoft person associated with it. We have pipelines that run and validate each of these. So we have resources, we have patterns, we have like utility helpers, and we get availability zones configured by default. We have disaster recovery patterns. We get monitoring and hardening. Like these are building blocks for you to go start using like right away. So this is the APRL website, Azure or the AVM website. And if you look here, they'll have like the intro and tell you about it. But we've got Bicep and we got Terraform. So we got both of these. And you can see we got 168 that have been published. You can see on each of them, they're versioned. We usually have somebody maintaining them. The pipeline that runs, yep, we have some that are not maintained right now. But I can, come on, click on the link. Okay, there we go. Froze for a sec. So I can go in here, and what I really like about the AVM setup, this is kind of cool. It will tell you all of the types that are used by the module, and there's links out to the types, including the reference documentation, and then I can see examples. So if I just want an example of the defaults, okay, like boom, I'll have a quick start like container app, and I can specify resources. I'll always put CPU and memory limits on your containers, folks. But then I can like look at more complex examples, and these are all like, oh, I want the large parameter set. Oh, I want a VNet with container app deployment. So these like are ready to go. You don't have to go out to the REST documentation and copy and paste and make your own Bicep module out of the reference stuff. Like this has already done all of that, and these are ready to go and be used. Now, this is probably, so AVM and APRL are probably the two things I really want you to leave with if you haven't, like if you don't go out and spend time on the well-architected framework. So APRL, I used to use this up until I moved to my current role in Azure when I was, and this was used by many, many Microsoft consultants. This is used still. This is the Azure Proactive Resiliency Library. So this is a set of queries and tools that will run against your Azure subscription. Like you enable it to run against your Azure subscription, and it will run Azure Resource Graph queries against your stuff and tell you, this is not configured reliability. It'll do queries and be like, hey, you have a VM scale set that's not set to use availability zones. Hey, you have this thing and it's set to use the basic SKU and not the premium SKU that gives you reliability and redundancy. You can run it as a PowerShell script. You can run it. So if you come here, there's this link right at the top of the Git repo. This is the Proactive Resiliency Library. So you can look at like resiliency recommendations. You can look at for reliability. But I like to look at the like individual resources. Like you run this, and essentially it does all of these checks. So like high impact, high availability, automation is available. Some of these are already in Azure Advisor. So when you're on Azure Advisor, you might see some of these recommendations, like enable soft delete, but on other ones you won't. And like, I want to make sure all my storage accounts are zone redundant. That seems important. And I can come down here and I can click this. It's going to run this query against every single storage account in my subscription if I want it to, like through the tooling. And it'll find anything that's not, or anything that's like LRS, because that's not reliable. And it'll give me a report and says, hey, this stuff's not reliable. If you go to tools, you will see that there is a tools on a collector, an analyzer, and a report. These are PowerShell tools you run, and you can run the collector against a subscription, a resource group, or with filters. So you can run all of these queries against only the resources you care about, and then you can get like a analysis, and then you can get a report, and you're going to get like a report back. I think I had one open that I had done a while ago. Yeah, or Yeah, so these were pretty much all run by this. So, you'll see the subscriptions that you have and the issue that's wrong with it, and it spits out these documents that you can then review. You can go through and look at the impacted analysis. You can do planning. You pretty much get all of this just by running some of these scripts from this repo, and it will help you dramatically improve your resiliency of your tooling, of your subscription and your platform. Yeah, so we've got service-specific recommendations. A lot of those are in the well-architected service guides. We've got specialized workflows, all the graph queries, the WAF recommendations, all those are baked in. Another thing my team helped work on was Azure review checklists. Now, this is more of a self-guided go check thing, and this goes far beyond April. These review checklists, now this team doesn't exist anymore, but we helped write Fast Track for Azure. These are checklists. So these are lots of things, and there's checklists for landing zone, for AKS, for security, for WAF, for AI. Essentially, it's just a long list of questions, but those questions you can use to help guide, did I design my thing right? Am I missing some best practices? Is another really good resource to dive into, just to help validate and communicate. From AI/ML to a container deployment to something like applications and Spring Apps or data, cost reduction. We had a lot of tips and tricks in there that you could go through the questions, and you could filter out on the resources you're using, and there would be specific guidance on how you could help improve. So we've got lots of tools. Understand your business requirements. That is the biggest thing I can tell you. Understand what the actual application is doing. Don't just take, I need 100% uptime. What's the most important user flow? What is the thing that our company is doing that is critical? And let's actually prioritize some of the requirements. And how much pain are we willing to take? If you want to have it cost all the way to dial down to 1, how much are we willing to take pain? And how much do you actually want to be in a place where we can recover and be resilient against some of these things? Try to use that to influence your architecture, leverage the things on the platform, leverage the things in the language design and SDKs, and then use some of the tools I've shown you to help validate and test your own systems. So thank you guys all for coming. I appreciate it. Feel free to connect or reach out and get any of these resources. Again, everything's out on my GitHub, CodeBytes. So thank you all.